Hello everyone. Today we are going to discuss the chemistry of group 15 elements. So we are going to discuss basically these topics today. Members of group 15 and their sources, electronic configuration and oxidation states, variation of atomic sizes, variation of ionization enthalpy and electronegativity, and anomalous properties of nitrogen, and study of their hydrides and oxides. Okay, now first of all, group 15 elements are present in the right side of the periodic table, uh, starting from group number 13 to group number 18. These are the p block elements. Okay, so here we are going to discuss the chemistry of group 15 elements mainly, because we have already discussed the group 13 and group 14 elements in class uh, 11. So first of all, uh, what are the sources of these elements? Nitrogen, phosphorus, arsenic, antimony, bismuth. These are the 5 elements that are present in group 15. Okay, as you can see over here that nitrogen is present almost by almost 78% by volume of atmosphere. Moreover, the nitrogen is present as minerals in the form of sodium nitrate and potassium nitrate, as you can see over here. Now phosphorus, what are the sources of phosphorus? Phosphorus are mainly found in the form of minerals. Okay, and also in milk and egg in the form of phospholipids. Okay, what are the sources of arsenic, antimony and bismuth? Arsenic, antimony and bismuth are mainly found in some sulfide ores. As you can see over here, arsenic sulfide H2S3 and antimony sulfide Sp2S3. So these are the primary sources of these uh, 5 elements. Okay, now let's go for the electronic configuration and oxidation states of these elements. Okay, so general electronic configuration of these group 15 elements uh, is NH2 NP3. Okay, and what are the possible oxidation states? The possible oxidation states are -3, +3 and +5. Now what is the reason behind it? The reason is very simple. As you can see over here that there are 5 electrons, 2 electrons from the s orbital and 3 electrons from the p orbital are present here. So there are total 5 electrons in the outermost orbit of these elements. So they have two choices: either they accept 3 electrons more from outside and exhibit an oxidation state -3. Okay, or they can reject all the 5 electrons that are present in the valence shell and exhibit the oxidation state +5. But one thing is very important to be observed here, that the heavier members of this group, such as antimony, as you can see over here that arsenic, antimony and bismuth are the heavier members of this group 15. So for this arsenic, antimony and bismuth, there is additional oxidation state, that is +3 state along with +5 state. Now what is the reason behind it? The reason is very simple. In the electronic configuration of arsenic, antimony and bismuth, as you can see that there are d electrons, there are d electrons and f electrons present in the valence shell configuration of these elements. As we have already learned in class 11 that d and f electrons have very poor screening power. Okay, now due to having very poor screening power, the electrons of the outer shell will be strongly attracted towards the nucleus. Okay, now as you can see over here that there are 2 electrons in this s orbital, that is ns2. So these 2 electrons will be tightly bounded with the nucleus of these atoms. Why will they be tightly bounded? They will be tightly bounded because of the poor screening power of d and f electrons that are present in the valence shell configuration of these elements. Okay, now as these 2 electrons of s orbitals are tightly bounded with the nucleus, these 2 electrons will not participate in the chemical reactions. So these 2 electrons of s orbital act as a inert pair. Okay, so in spite of having 5 electrons in the valence shell, only the 3 electrons of the p orbitals will be used in the bond formation or will be used in the chemical reactions. So that's why the heavier members of group 15, which are arsenic, antimony and bismuth, they will exhibit +3 oxidation state rather than +5 oxidation state. As you can see over here that the compound like BiCl3 and SbCl3, what are the oxidation states? The oxidation state of bismuth and antimony are bismuth and antimony is +3 rather than +5. So why is it happening? It is happening because of poor screening power of D and F electrons. Okay, now what is the size variation of these group 15 elements? Okay, as you can see over here that the size of the elements are increasing from nitrogen to phosphorus to arsenic to antimony and to bismuth. Size is increasing continuously from top to bottom along the group of group 15. Along the group, we are observing what we are observing. We are observing nitrogen to bismuth. The size is increasing. Now, what is the reason? As we have learned in class 11 that whenever we move from top to bottom, a new cell is introduced in the atom, and that for this reason the size of the atom is increased. Okay, now one thing is very important to observe. One thing is very important, that is from arsenic to bismuth there is a slight increase of size occurs. Okay, as you can see over here that from arsenic to bismuth, what are the sizes? Arsenic 121 picometer, antimony 141 picometer, and bismuth 148 picometer. Okay, so the size increase of size is very much less while going from arsenic to bismuth. So what is the reason? The reason is again the screening effect of D and F electrons that are present in antimony and bismuth. The screening effect of D and F electrons that are present in antimony and bismuth is very very poor. Okay, and for this reason the size uh, will be increased by less amount while we go from arsenic to bismuth, because of the poor screening effect of D and F electrons who are present in arsenic, antimony and bismuth. They will not allow to increase the size in a greater amount. Okay, now what is the variation of ionization enthalpy and electronegativity for this group 15 elements? Okay, so let's talk about ionization enthalpy. As we have observed over here that nitrogen to bismuth, the size is increasing continuously, and for this reason the ionization enthalpy will be decreased due to increase in size. Okay, now one thing is very important here, that what is the general expectation of us, that group 15 elements will exhibit a lower ionization enthalpy than group 16 elements, because as we have learned in class 11 that from left to right in the periodic table the ionization enthalpy increases. So group 15 elements should exhibit less ionization enthalpy than group 16 elements, but actually the group 15 elements exhibit a higher ionization enthalpy than group 16. So what is the reason behind it? The reason is very simple, that as we have discussed in the earlier topics, that group 15 elements have the electronic configuration ns2 np3, and that is a half filled cell of configuration. And in class 11 we have learned that the half filled and full filled cell configurations are very stable configuration, and for this reason it's very difficult for us to snatch or to take out one electron from the outermost orbit of the from these group 15 elements, and for this reason group 15 elements will exhibit a higher ionization enthalpy than group 16. Okay, now let's talk about electronegativity. There is a regular decrease of electronegativity from nitrogen to bismuth, because the size is increasing continuously from nitrogen to bismuth. Now we will discuss about some anomalous property of nitrogen. As we have learned in class 11 that the first member of each group in the periodic table exhibit some unusual properties, some irregular properties. Okay. So like following that trend, nitrogen will also exhibit the same kind of irregular properties. What are the reasons behind it? The reasons are very simple. Here you can see, due to smallest size, highest electronegativity, and highest ionization enthalpy, nitrogen exhibits some unusual properties in comparison to the other members of its group. And another reason is that nitrogen doesn't have any d orbital in its valence shell, because nitrogen is a member of period number 2, so it has 2s and 2p orbital in its valence shell, so it has no d and f electrons. For this reason, for the non-availability of this d orbital in its valence shell, nitrogen exhibits some anomalous properties. Now, another reason behind this anomalous property of nitrogen is excellent ability to form pi-pi bond with same or different element. As you can see over here, that the compound nitric oxide NO, nitrogen is forming pi-pi bond with oxygen. Okay. And due to similarity in size between nitrogen and oxygen, they are easily forming this type of compound by the formation of pi bond. Now, it's very important to observe one thing, that is, the other elements except the nitrogen, other elements like phosphorus, they can expand their octet. Okay, because they have uh, d and f orbitals in their valence shell, so that they can expand their octet. As you can see over here, that phosphorus is surrounded by 5 bonds. 3 bonds are connected with 3R alkyl group, and 2 bonds are connected with oxygen. So there are 10 electrons around phosphorus. Okay, here also there are 10 electrons around phosphorus atom. Okay, so phosphorus is expanding its octet, but nitrogen will not be able to expand its octet, and for this reason, anomalous property is shown by nitrogen. Now we will see some trends in the hydride, trend of some properties of the hydrides of group 15 elements. So first of all, I'd like to say one thing, that group 15 elements always form hydrides of the type MH3. Okay, MH3 type of hydrides are formed by these group 15 elements. As you can see over here, that this picture contain M element as a central atom, and they are connected with 3 hydrogen. Okay, what is M here? Here M is nitrogen, phosphorus, arsenic, antimony, or bismuth. Any atom among these atoms can be represented by M. Now, we are going to discuss about some properties. What is the variation of some properties across these as we move from NH3 to BiH3? As you can see over here, that as we move from nitrogen to bismuth, size of the elements are increasing. As the size is increasing, the length of the MH bond, the length of this MH bond will be increased. As the length is increasing, the bond strength of MH bond will be very less from nitrogen to bismuth. Okay, and it's very easy to rupture this MH bond. That means as we move from nitrogen to bismuth, that means from NH3 to BiH3, thermal stability decreases. Okay, now we are going to discuss about the reducing property. What is the variation of reducing property? For the same reason, we can explain that as the size increases from nitrogen to bismuth, MH bond strength decreases, and the electrons of this MH bond will be more available to reduce other compounds. Okay, and for this reason, as we move from NH3 to BiH3, the reducing property increases. Okay, now the last variation of property, that is the basic character of these hydrides. As you can see over here, the basic character decreases. Basic character decreases from NH3 to BiH3. We have to keep one thing in mind, that basic character of compounds depends on the charge density of central atom. More the charge density of the central atom, more is the basic character, because the basic character is nothing but the capture of proton. by a central atom. Okay, so from nitrogen to bismuth, due to increase in size of the central atom, the lone pair charge density decreases on that central atom. Okay, so the chance for the, as the lone pair charge density decreases on this central atom M, the chance for the central atom to take a proton decreases, and consequently the basic character decreases from NH3 to BiH3. Now the last topic that we are going to discuss here, the oxides of group 15 elements. The oxides of group 15 elements are basically of the type M2O3 and M2O5, where M atom represents the group 15 elements. So as we have observed, as we are going to see here, that nitrogen oxides and the phosphorus oxides are acidic oxides, arsenic and antimony oxides are amphoteric oxides, and bismuth oxides are basic oxides. Okay, now nitrogen oxides and phosphorus oxides are acidic. Why they are acidic? Because as we have learned in class 11 that the character of the basic character of a compound depends on the ability of that compound to liberate oxide ion. Okay, so nitrogen and phosphorus being smaller in size, these nitrogen and phosphorus atoms are not going to lose this oxygen atom. Okay, and for this reason these compounds will not liberate the oxide ion easily, and for this reason these compounds are acidic oxides. Okay, as we move from nitrogen to bismuth, we are observing, what we are observing, we are observing basic character of the oxide increases. Okay, bismuth oxide is the maximum will show, bismuth oxide will show maximum basic character. Why bismuth oxide will show maximum basic character? Because the bismuth being larger in size, the bismuth oxygen bond length is higher, and for this reason bismuth will lose the oxygen atom in the form of oxide ion, and consequently basic character appears in this compound bismuth oxide. Okay, so these are the some important topics of group 15 elements. The rest topics will be coming up in the next video in the next week. Till then, thank you for watching this video.